Okay, welcome back. In our last lesson, we had an introduction to the law of indices, and we found that there were 4 forms that a number can be expressed in. And in this way, expanded was number 1, the index was number 2, and number 3 was our prime factorisation. Okay, to start delving into the specific laws, and we need to know that there's actually 5 index laws. Sometimes you'll hear it as the laws of indices, but just for the ease, we're going to call it 5 index laws. So let's start with law number 1. So law number 1. So what number 1 tells us is that when we are multiplying our terms, let me write this down for you, multiplying our terms with the same base. Now, hopefully you remember what the base is, and I'll remind you in a moment. But when we're multiplying terms with the same base, we add the powers. So you may remember that if we had the number 5 to the power of 4, that this number here is the base, and this number here is the index. So law number 1 says when we're multiplying the terms with the same base, we add the powers. So this is what this actually means. So if we had 5 to the power of 4 plus 5 to the power of 3, we need to add the same base. Sorry, I've made a mistake. Let's back up because I'm confusing you. Back. If we have 5 to the power of 4 multiplied, so multiplied here, by the power of 5 by the power of 3, we are multiplying the terms here, we add the powers. So essentially that means that 5 to the power of 4 by 5 to the power of 3 is actually 5 to the power of 7. Because we've added this 4 plus this 3, which equals this 7. So this is still an index. Okay, and this is still the base. When we have index laws, there are actually 5 different laws that we need to be aware of when we're actually solving an equation. And the first law, number 1, states to us that when we're multiplying, so law 1 is when we're multiplying terms with the same base, and you might remember what the base is, we add the powers together. So let me show you what that looks like. So we have the number 5 and we have to the power of 4. You would remember that the 5 is our base and the 4 is our power. So what this law is saying is, if we had the following equation, for an example, let's say we had 5 to the power of 4 multiplied by 5 to the power of 3. What the law states is that when applying the terms with the same, I should actually say with same base, okay, so the same base here, 5 and 5, it's the same. So we can write 5. Then we must add the powers. Here are our powers. So ultimately, we are adding those together. So it'll look like this. Actually, let me make it black so you can see what's going on. So 4 plus 3 equals 7. Okay, so let's try that again, just to reiterate what I'm trying to say. So we had the figure 3 to the power of 5 multiplied by 3 to the power of 2. Again, up here, when we're multiplying, we're with the same base. What we're saying is that we need to add the 5 and the 2. So in this case, we have 3 to the power of 7. Okay, so what we're doing here now, the same applies when we have a pronumeral. Now you may remember a pronumeral is basically a letter that is assigned to when we don't know the value of that particular item or term. For example, we could have A. So if we had A times A, and they both had, say, the first one had A to the power of M, and the second one is A to the power of N, then because it's the same base, we know that it's an A. And remember, the powers up here, we need to add them together. So in this case, it would be M plus N. So just because there's no number value associated, it is actually a pronumeral up here, it still means the same. Okay, so we're going to move now to index law number 2. So very similarly to index law number 1, when we divide terms with the same base, we subtract the powers. So it's very similar to law number 1, except in this case, instead of multiplying, we're actually going to divide. Ooh, let me fix that one. Okay, so again, for example, if we had 5 to the power of 2 divided by 5 to the power of, actually, let me take that back. Let's say we had 5 to the power of 6. Divide by the 5 to the power of 2. Now we know that because we're dividing with the same base, then what we need to do with our powers up here is we need to subtract them from each other. So the answer to this one would be 5 to the power of 4. Okay, because 6 take 2 equals 4. Again, it works the same way if we were having pronumerals. So let's say we had x to the power of b, take x to the power of a. Again, same base, so we can write that down. X, b, take a. So again, it would be b take a. Okay, so let's just do a little bit of a practice to consolidate your understanding. So in the book, you might see that we've got an example of 3 to the power of 6 multiplied by 3 to the power of 4. So we're looking for the same base, so we know that that's 3. Because we're multiplying here, which is right here, we know that we've got to add our powers, which is 6 plus 4. So in this case, it's 3 to the power, 6, let me use my right. Oh no, back it up. Okay, so we know that this is going to be 3 plus 4. But we can write it even more simply than this. So in this case, we would go 3 plus to the power of 10, because 6 plus 4 is 10. Okay, now let's do the same thing, or very similar, to what if we were going to divide. So let's say we have 7 to the power of 9 divided by 7 to the power of 4. We know our base, it's going to not change, it'll be 7. But up here we need to go 9, take 5. So if we go 9, take 5. So what I'm doing, I'm actually showing my workings here, which is good because, which is what I want you to do, because then I can see your thinking. So 7, 9 take 5 is 4. So 7 to the power of 4. If we were working with the pronumerals though, unlike up here where we've been able to express this number here, right, we've been able to simplify it and actually call it 10. Same here, we've been able to simplify 9 take 5 and come up with an answer of 4. However, when we're dealing with pronumerals, we leave it as we see it because we don't know the value. So for example, a to the power of m plus a to the power of n, we've already established that, I've written the wrong one, let's go back. It's x, so a to the power of m by a to the power of n, so it's a m plus n. Now remember, I got this figure here, or this value, m plus n. Because I don't know the values of these two, I can't actually put mn, because if I did, that would make it look like a multiplication, and it's not. It's supposed to be a plus. Similarly, if I was going to divide, so I had x, let's make it 7, divided by x to the power of 2. So we know that x is our base, they're the same, but unlike before, rather than adding, we're taking away. Okay, so we're this, take this. Okay, so 7, take 2. And that's how we write when we have pronumerals, so unknown values.